Good evening, y'all. Welcome back to another Sunday night Electronics Bash Fundamentals of Electronics stream. I'm Jeff. Most of you know me by now, or maybe you're new. Maybe you're a brand new person and you've never been here before. Or I guess maybe you're a brand new watcher and you've never been here before. If you're a brand new person, if you're an infant, welcome to you too. You're really getting a leg up on all this Python stuff. It's going to be a fun night, y'all. I got a kind of a new setup going on here. As always, we'll take just a few minutes to pause before we... Electronics Bash is old enough to drink. Yeah, it's true. I can't believe I was saying to my wife earlier, it's been just over 5 months since we started doing these, which is pretty wild in the grand scheme of things. But it's been fun, and I'm excited to sort of have launched a sort of a new arc of them because I think that'll be a lot of fun. As I was saying, as always, we'll get started in just a couple minutes here. We'll get some stragglers a chance to catch up. As always, all the slides are linked on the website, jeff.glass/electronicsbash. There you'll find all the slides. I haven't put up any code for this evening, though we will be writing some code, mostly because the examples that I would write are not terribly complicated. But I did occur to me that a couple of things we might do might get a little more involved, and I'll put those up there after the stream, just if you're curious as to what the final structure of them looked like. You can piece through them there. But today's going to be, going to be about burping, as always, because tonight I'm drinking a tasty Pinball Pale Ale from Two Brothers Brewing Company in Warrenville, Illinois, a delicious pale ale. Tonight's going to be about drinking beer and hopefully remembering to mute the mic when I do it, and also fundamentals of Python programming. So last week, we talked a little about what the Raspberry Pi is, how it's different from Arduino, what it can do. This week, we're going to dive into Python, which is the programming language that we're going to use to start making the Raspberry Pi do some things. Hey, Palmer, how's it going? As you all might be able to tell, I don't mind giving you nerds a peek behind the curtain. The setup is a little bit different today. I have incorporated another monitor into my setup, which I thought was going to sneak right in really nicely, but the monitor doesn't fit under the existing shelving in my space by a quarter of an inch. So rather than having that, here, I'll show you. Instead of having that nice big workbench space, right now, if we go to the table cam, you can see that's the edge of the desk and the keyboard for the Raspberry Pi is here. It's a little bit crowded because this monitor is taking up all this space, which means that the camera's in a slightly different place. The preview view that I have of what you're seeing is in a slightly different place. The chat's in a slightly different place. So if it seems like I'm a little bit off my flow in terms of where the cameras are, it's because they're in a different place than they have been for the past 5 months. So we're gonna kind of roll with it. Good time for the office redesign. Listen, as soon as I start getting sponsored and turn this into a full-time career, I will absolutely reorganize this space to be more streaming appropriate. But until then, this workshop has to be both the programming space, the streaming space, the assembly space, the mini moving light demo space. So I'm trying to keep as much room as possible. Yeah, Palmer, the new monitor is awesome. It's really good. So a little peek behind the curtain, and then I see our timer's done, and we'll just dive right in. For the first Raspberry Pi demos last week, I was actually viewing the output of the Raspberry Pi in my streaming software, shrunken down, in all the little preview window. Now what I have is a full monitor view of my Raspberry Pi desktop, and then a splitter to capture that into the streaming software, which both means I have a view that's, a full monitor size instead of a little preview window size, which is pretty awful. And there was 200 milliseconds of lag previously on the Pi desktop, which you can't see because, of course, you're not looking at it in real time, but it made everything feel just a little, imagine if your mouse had 200 milliseconds of lag. Everything just feels a little bit floaty. So I think we've solved that problem. So it's selfishly going to be really nice for me. You know what also will be really nice? Diving right in. That's a good segue right there. Also, just like last time, you might see those little loading windows popping up. That's just a way of me navigating having the Raspberry Pi desktop as an additional capture source. But that's all right. Ooh, I've got this little annoying window down here. Kill that. Let's talk about Python, y'all. It's going to be a good night. We're going to talk about a little bit what Python is. Spoilers, it's a programming language. We're going to talk about programming in Python on the Pi and the tools we'll use to do that. We'll talk a little bit about, tonight's going to be an introduction to the Python programming language, a little bit about structure, variables, numbers, and we're going to touch briefly on the difference between an interpreted language versus a compiled programming language. And we'll get to the details of what that actually means in just a little bit, because it'll be relevant to some of the cool stuff that we can do in Python that we couldn't necessarily do, say, in C or Java or C++ on the Arduino. Cool. Let's dive in. A brief history. So Python, as I guess I should say, Python is a programming language. It's a sequence of words and commands that you can use to make a computer do something. I think most of the folks who are with us tonight are probably here with us for the Arduino series of classes as well, and so are sort of familiar with the Arduino language as their base, which is based on C++. Python is a slightly different construct, but at its core, you're writing things that are much like English words in a very specific structure, a specific form factor that the computer can process and understand to know what you're asking it to do. So some real brief history. Python was originally released by Guido van Rossum in 1990. Guido only very recently departed the Python project in 2018. Until then, he was what Python called the benevolent dictator for life. And basically, like, anything that had to do with Python, ultimately, it was his decision. He just promised to be nice and good and diplomatic about it. And in 2018, he decided he was sort of done with that role, and sort of ceded his responsibility back over to the Python community. So Python is still under development. Python 2 was released in 2000. Python 3 came out in 2008. All of our work that we're going to do is going to be in Python 3. Specifically, the tool that we're using will be based around Python 3.7. There's not a huge number of differences between all the different variants of Python 3, but Python 3 and Python 2 are significantly different. So if you end up looking up example code on the internet, it's not uncommon to see, like if you were looking up, like, how do I print some text to the screen? It'd be very common to see in Python 2, it looks like this. In Python 3, it looks like this. And they'll be similar, but not compatible with each other. So just make sure that you're using the version of Python that we're going to be using, which is Python 3. That's partly because Python 2 is deprecated. It's unsupported. It's not changing anymore. It was originally supposed to sort of be like shut off in 2015, and there was enough active Python 2 code running out in the world that deadline got pushed back actually until just earlier this year, pushed back to 2020, until it was finally like, hey, if you're still running on Python 2, you've had 20 years. You've had 12 years since Python 3 came out. It's time. Make the switch. But they are different. I should say, so as usual, I've made slides. They're on the website. You can look at them if you want to. A lot of them are going to tell you things that I would rather just show you in the programming environment. So if it seems like a lot tonight, especially when we get to like bits of code that I go to a slide for 4 seconds and then leave it behind and we go back over to the Pi and do things, it's just because I think it's more interesting and more informative to just show you what the code looks like rather than read a slide at you, if that makes sense. We'll do the exact same examples. I'd rather just do them in the code. But real quick, before we get there, I want to tell you, I want to show you the tool that we're going to use for programming in Python on the Pi, which I noticed in the title of my slide I have misspelled here. We're going to making use of, or at least I'll be making use of, the Thonny IDE, or Integrated Development Environment. You have lots of different choices of development environments on the Pi, and on Windows and on Mac and whatever you're using. I know there might be some folks out there who haven't gotten a Pi yet or are on the fence about it. You can learn about and write Python code on basically any computer. You can actually download Thonny for Windows or Mac as well if you want to. It's just a nice one that comes shipped with the current operating system from the Raspberry Pi. So I think it's a nice place to start. It's both powerful and simple. It's like a nice middle ground, so we'll use that. If you're looking for it on the Pi, if we come to our desktop here, so I'm going to peek over and make sure that loaded. Yeah, very good. I'm going to make sure I can actually see the whole screen. There we go. If we come up to our Pi menu in the top left here and click it, we come down to the very first tab, which is the Programming tab, and click on Thonny Python IDE. That's where that's going to be. It's going to boot up in a second here. And you can see I typed some code earlier, but if you're opening it for the first time, this is probably what you will see, which is the Thonny IDE. So a blank space to write our code and some other things that we'll look at in a second here. I will say if for some reason your installation on the Pi does not have Thonny included, then there is a terminal command that you can run to make Thonny install. It's this one here. If that's the case for you, I suggest download the slides and just run that command in your terminal. It'll take a couple minutes and you'll install this program. If you're running on Windows or Mac, just Google Thonny IDE. Takes you to their very nice web page and you can download it from there. Cool. Shall we get into writing a little code? I think so. Let's see here. So a brief preface. about syntax and programming languages. Palmer says the Pi would need to be online. Yeah, so if you were needing to download that program, your Pi would need to be connected to the internet. If you're running on a Raspberry Pi 4 or a 3 that has Wi-Fi, you can connect it to one of your various Wi-Fi networks here. I've got mine's telling me it's a 5 gigahertz network, that's awfully fancy. I didn't know it would indicate that. Or you could plug it into your Ethernet network. But like I say, so I downloaded this image of the Pi like a week and a half ago, and Thonny was included. So I am assuming if you've done the same that it will be there. If you're running on an older version of the Pi, it may not be, but the program should still run. It's a good question. If you're coming from the Arduino world, and I imagine many people are, just to put you in the frame of mind of what we're about to approach, Python is a different programming language from Arduino language or C++, but they share lots of similar ideas. They share lots of similar sort of programming concepts. And we'll talk about a lot of the fundamental ones tonight, like variables, the idea that you can attach a name to a value in a variable, various kinds of loops, and an if-then statement. Like, these are concepts that are so fundamental to the idea of what we think of as programming in most contexts that they're in many languages. The specific ways you write them, the punctuation, the form factor might be slightly different, but to me, it has always felt a little bit like if you know some Spanish and you try and read some Italian, right? It's like, oh, I don't know exactly what's going on here, but I can see, oh, there's prepositions and the word order is a little bit different, but the concepts are very similar. So you can always read the manual if you forget exactly what the syntax is. I do all the time. In fact, there's a really decent chance that at some point, if not tonight, then in the coming weeks, that like I'm gonna have to be like, oh, hang on, let me Google exactly how you do this subject. Like, that's just a part of what programming is referring back to the user's guide of like how all this stuff works and Googling what is the best way to do this in Python. So know that if you're doing that, you're right on track. I put a link in this slide to a tutorial / reference that I really like, but there's lots of good references out there. So, all right, now I promise, let's just dive in. Let's start with the comment. And like I say, you see, I've already switched away from the slide because I'd rather just show you in the text editor. I picked a pretty large text size. If this needs to be larger, so you can actually read it over there on the other side of the internet, let me know. Happy to blow it up more. So comments. Comments are any line of text that we do not want to run as code. They might be there to remind us what a bit of code does, or where we're starting or ending, or things we still have to do. In Python, any line that starts with what we would call in today's parlance a hashtag or a pound symbol is a comment. So this is a comment. You can see it's putting it in this light gray text for me here in the editor, just to remind us that like that's not really code. It's just some text that I wanted to put in there to remind myself of something. You can also, if you have some code, and not to get too far ahead of ourselves, but let's say I had a bit of code here. If I prepend it with a pound sign, I can say this is also a comment, right? So I can have some code at the beginning of the line, a pound sign, and then a comment that follows it. If I wanted to have multiple lines of comments, I would need to say have a pound sign at the beginning of each of them, just so each of those lines is sort of individually commented out. Cool? So when we're making notes to ourselves as we go tonight, I'll be using this to sort of annotate where we are. Cool? That's real straightforward. That's just comments, right? Shall we, let's get this program doing something. Let's get it showing something on the screen, right? So I'm going to delete all this, and we'll show how to write a really basic bit of code and how you run it within the Thonny IDE, right? So I think I have a slide here. Yeah. So the first programming command in Python we're going to learn is called print. It's the lowercase word print, a pair of parentheses, and the thing inside those parentheses is the thing that you're going to print. And just to get a little pedantic about it, which doesn't sound like me at all, I know, where you're printing to is a place called the standard output of a program on your computer. This is a little bit different than like when we were in the Arduino mindset and sort of we had a pretty defined set of inputs and outputs. This program is going to run on our computer. But what does it mean to have a program run on our computer, right? If I can't have my web browser run a print statement. Does that print to my printer? Does that print to my screen? Where's it going? Well, by default, a program running in a Linux environment, when you use this print statement in something like Python, or in many other programming languages, goes to what's called the standard output for that program. And most of the time, that is sort of output to nowhere, right? If my web browser on my Raspberry Pi here was to say print something, well, there's no output, there's no standard output that's sort of designated for the web browser, so it just silently goes away. One of the things that our IDE, that Thonny, does for us is say, hey, if your program emits some output, if it prints something, I'm going to show it down here in this shell, so that we can see what it's doing. There are ways of like redirecting that output to a log file. There's also other ways to log things to a file, and various things. But just know that like if you're running a program outside of an IDE and you want it to show some text, you can't just say send something to out into the world. You have to specify where it goes. That's probably getting a little bit deeper than we needed to go tonight, but like I don't know what you expected. You guys have been here. So the print command. Let's looks like this. We'll do lowercase print, open parentheses, and inside of quotes, either single or double quotes, and it doesn't matter which. I like to use double quotes just to be consistent. I'm going to say, hello, Chris and Palmer, right? Then to run my code, I have a couple options. I can hit this run button up at the top here, or I can press F5, which is the hotkey for run. The first time you run your code is going to make you save it, so I'm going to save this in my Python programs folder here, if it'll ever open. It's thinking about it. You'd like to open. There we go. I'm going to call this hello CNP, right? Hit OK. Now it's saved it, and you'll see down here at the bottom, it says I've run hello CNP.py, and its output hello Chris and Palmer, right? So that's the print command, really simple. Print can do strings, right? So I can write another print statement, hello again, and if I run that, it says hello Chris and Palmer, and hello again. It can also print numbers, right? So I could print the number 3. I could print a decimal number with as many sort of decimals as I want to, right? And it prints that number just directly out to the screen. It doesn't really matter what you put in there. It will try and print it out for you. So print, real easy way to get some output onto the screen. Let's talk a little bit more about what those things might be. Strings. A string just means text, right? And if you're coming from the Arduino world, this should ring a bell. String just means some words, some text, some data that represents language as opposed to a number. Like I say, single quotes, double quotes, it doesn't actually matter which. They're completely interchangeable. You should be consistent just for like readability, but it doesn't really matter. You can smash two strings together, or what's called concatenate them, with the plus command. So you see the example in the slide here, hello plus world becomes the combined string hello world. You can also duplicate them. That you can say, ha times 3 is ha ha ha. So let's look at that example real quick. So I could say hello Chris and close that string, add a plus symbol, and open up a new string and say hello Chris and Palmer. And when I print that out, it becomes one string, hello Chris and Palmer. You can also you can also multiply things. If I say hello times 3 and I print that out, I get hello, hello, hello. Real simple. I want to talk about numbers, and then I want to talk a little bit about printing numbers with strings here in a second. I've crashed my stream controller again. Hang about, you cool nerds. Let me restart. If this ever happens to you, the trick seems to be restarting your Bonjour service on your computer. So there's a cool bit of trivia for you. Bonjour service. Restart. Then you restart your Stream Deck, and it's a whole thing. We'll see if that wants to come back. But in the meantime, are we here? Yeah, there we go. Let's talk a little about numbers. So something you may have already noticed in comparison to working in, say, C++ or Python, or C++ or Arduino, is that we didn't have to declare what type of number we were working with earlier. I said 3 or 2.everyone. Numbers just are numbers in Python. In fact, there's two different types. One is an integer, which has no decimal part. The other is a floating point number that has a decimal part. And the only reason that those two things are different is that when you're dealing with numbers with decimal parts that are floating point numbers, it is possible that when you add them up, they won't quite add up to a whole number. And Python says, well, if we're working in whole numbers, we're going to stick in whole numbers. But once we start working in decimals, then we're going to sort of work as high a precision as we need to, if that makes sense. We have plus, minus, divide, and multiply. Those work just as you expect them to. We can do in-place operations that I'll show you in just a second here, and we have exponentiation as well. Let's see, Stream Controller is still throwing up on me, but I think we can make this work. I really only need, like, look at the computer and look at your pretty faces. Oh, Palmer has a question. Palmer says, if you added a space after hello, would it add it into the 3? Ah, yeah, good question. So if I take this string here and I put a space after the hello, when I add that in, what I get is hello, hello, hello. But of course, I also, you can see if I highlight it here, I have a trailing space after my final hello, because it's printed that literal string 3 times, if that makes sense. Good question. So let's look at some numbers here. Just so we have something to print out, I'm going to say print print 3 should hopefully print 3. Great. I can print 3 plus 4. And then run that, and I get 7, right? Numbers work as we would expect them to. I can print 3 times 4 is 12, right? I can print 3 divided by 4, and it will just do that math for me. It's 0.75. That's awfully convenient. I can do 3 to the power of 4, which in Python notation is 2 asterisks, and I get 81. Chris says, does the all lowercase matter? It doesn't in Arduino, correct? So in this case, Chris, yes, it does need to be an all lowercase print statement. In Arduino, it should matter. Things are pretty much case specific there. For variable names, it doesn't matter whether you're uppercase or lowercase as long as you're consistent, but the commands themselves typically are. And you can see Thonny's helping us out here. Print has turned to this purple color because it's spelled correctly. If I uppercase it, or if I typo it, you'll see it turns back to black, which is its color for, I'm not entirely sure what this is. But as soon as you get a statement that it knows about, it color codes it for you, so you can tell you've typed it correctly. What other things can we do here? That's the gist of the basic math functions. Let's talk about printing numbers just a little bit here. So here's a couple of statements: print 3 plus 4 and print hello plus Chris and Palmer, right? And I run those and I get 7 and hello Chris and Palmer, just like I thought. But you'll notice we're using this plus statement twice to mean 2 different things. In this case, it means add these 2 numbers together. In this case, it means concatenate these 2 strings together. So if I say something which combines those 2 meanings, like I have plus 7 plus pineapples, let's say, and I try and run that, you'll see I first get 7, I get hello Chris and Palmer, and then I get an error. It says I can only concatenate string and not integer to string, which means, hey, I had this string and I see a plus sign, so I think I should be smashing this into this string to make a new string, but this is a number, not a string, and I'm not sure if you mean me to add something together or concatenate it, and I'm just going to throw up on you. In this case, you can use another built-in function called str, or the string command. And that just says, hey, whatever's in here, turn it into its string equivalent. So rather than having the number 7, I want to have essentially, I'll put it in a comment down here, the string 7. Right? So if I run that, I now get 7, hello Chris and Palmer, and I have 7 pineapples. Very good. Just a little thing to mention, because often what you want to do is print a little bit of text and say, hey, this number means something, and here's the number, and if you just try and smash that number onto the end of the print statement, it'll throw up on you. So the string function, will help us out there. Little tiny thing. Cool? Questions? Comments? Shout them out as always. I'm just going to plow on, because I'm excited for tonight. I love writing code in Python. It's very, very casual. What happens if you start with a number? Oh, let's find out. Print 12 plus pizzas in the oven. Run that. So this time it's a slightly different error, right? So it says unsupported operand types for plus, int, and string. So this time it says, okay, I see a number and a plus symbol. So I'm assuming we're doing integer addition, but this is not an integer. I'm just gonna throw up all over you, right? Just to allude to a point we're gonna make later, I'm gonna add a statement before this that says, hello, this is a statement. And afterwards, it's going to print, good question, Chris, right? So 3 statements here, and you'll notice this one still has that error in it, so it's going to throw up on us at that point. If I run that code, you notice it still said, hello, this is a statement, and then we got an error, and we didn't get that was a good question, Chris. Interesting behavior, and we'll get to why that is in just a little bit, but I want to put that seed in your mind now. Before we get to exactly why that is, I want to come back over here to the computer and talk really briefly about variables. And I know I'm slamming through some concepts. I'm trying to be totally candid. I want to build this up to a point where we can write a few simple programs and sort of get our feet wet a little bit, and not do the thing that I'm really prone to do, which is go really deep down the rabbit hole on some specific topic, like strings and numbers and what they are and exactly how they work. We could have a whole nerdy time about, but to just get things working, part of the beauty of Python is like if you put some letters inside of quotes, it's a string and it kind of just works. So I want to introduce a variety of topics tonight, kind of at like a an intermediate level, and get us working, and we can get to all the nerdy, complicated stuff later down the line when we want to. So, here, if you'll excuse me, I'm going to try and get this stream controller working, because having to click on the individual setting names each time I want to switch. Oh, well, and now, of course, it works. And now we're over here, and now we're back over here. Okay, thank you. Wow, love it. A variable, if you're coming especially from Arduino land or from any other programming environment, variable, it just means, a name that we assign to a value, right? Or a value we assign to a name, I suppose, really. So rather than, having just a piece of data floating around out there in the universe, we can assign it a name, a handle that we can think of that piece of information by. A variable can be a number or a string. And here's where I mentioned that you may end up with something unclear if you try to especially use that plus operator to add numbers and strings together. So let's do a little example here. To deep learn about integers, reference the Arduino bash. Yeah, we went pretty far down. It was like episode 15 or 16 where we talked about like memory inside of an Arduino and different byte sizes and like truncation. And that was I had a great time. I will not lie, but for the sake of us getting rolling in Python, I think this might be the way to go. Let's clear all that out. The way you assign variables in Python is really easy. If you're thinking about to Arduino land, you had to declare a variable with like a type, and we had to know how big it was. In Python, you can just start typing things, right? You can say my name equals Jeff. Right? Now I have a variable called my name, and it's the string Jeff. I didn't have to tell it was a string. It figured it out on its own. I could say my height equals 178. And I'll put a comma that says in centimeters. I actually don't know if that's accurate, but for the sake of this example, I guess it doesn't really matter. And again, I didn't have to tell this that it was going to be a number in advance. I didn't have to tell it was going to be a whole number. Now, of course, if I run this code, it's not outputting anything yet, so it just runs and then it ends. Nothing else happens. But now I have these couple of variables to work with, and I can use them in my print statements. I can say print, hello, my name is, and I could append the name my name, and my name, and my height is. And I'm going to do a thing here that's sort of good practice if you're writing Python code. When your lines get too long, let's say I started writing more and more facts about myself, and you start to scroll yourself off the screen, which makes it sort of hard to tell what you're doing at the beginning of the line, right? It's good practice to actually break yourself onto a new line. So in this case, I can actually just hit enter, go to a new line, and because I haven't closed these brackets yet, Python knows it means, hey, I just ran out of space. Like, don't consider this a new instruction. Just give me more room on a line to work with, right? So again, I have a string plus a string plus a string, and my height is, and I'm going to wrap this number in the str command, the string command, so that it prints, and then I'll add one more string to the end. Centimeters. Close that, close the brackets, run the code, and I get, hello, my name is Jeff, and my height is 178 centimeters. Did you both look up what my height in centimeters is? Can I get that in, what's 0.83 feet in inches? I only know my own height in imperial. This is gonna be great. So you see, it's really easy to start dropping variables into your statements here. You just put the name of the variable into your construct. If it's a number and you're trying to use it in a context where you need a string, you wrap it in this string function so it knows how to print out. And then, of course, as we change our... oh, man, I was real close with 178 centimeters. I think I'm actually closer to 174 centimeters then. Right, and if I change the value of my variable, if I change my height to 174, then when we get down here to the print statement, it references the value of my height, which is now 174. I could also change my name to be Jeff Glass, and here we are. My name is, well, really, my more accurate name is Jeff Glass. and my height is 174 centimeters. You can also, if you want to, do... Oh, I'm so close. Let's do 175. That actually, if I'm 175 centimeters, that will make me really happy for just like how nice a round number that is. I think that's going to be like spot on. So here, let me duplicate my print statement here just to show you a little example of how we can combine variables and math, right? Having my height in centimeters is fine, but maybe a little bit awkward. Let's say I'd like to print out my height in meters right after that. I could say inside of this string statement, hello, my name is my name, and my height is my height divided by 100, right? So my height in centimeters divided by 100 will be my height in meters. And when I run that, you'll see my height is 175 centimeters or 1.75 meters, right? So we can do this math inside of various other statements if we want to. So that's the gist of variables. Part of why I enjoy writing code in Python is because you can sort of just start typing things and Python will figure out what you probably mean, and it'll throw you a pretty clear error if you've gotten something where it's ambiguous what you might mean. You can just sort of start doing things like this, and I find that a really handy feature. Oh, but Chris says I could have done it in the code. Yeah, that's true. I guess I do have a means in front of me of like doing math using a computer. In fact, this is getting a slightly out of order in our slides, but let me show you a cool feature of Python, and specifically of a Python IDE or a Python interpreter. So we can run code in a couple of different ways. We can run code up here in sort of the programming area, but we can also run code down here in what's called the shell, right? So what this will do, if we start typing code down here, it will basically be as if we were executing code one line at a time as we type it in. So for example, up here, I could say 3 plus 4. That's a perfectly valid bit of Python code. It doesn't print anything. But down here, if I run it in the shell, it will automatically print the result of whatever we do, right? So I don't necessarily need to say print 3 plus 4, although I can, and you'll see it formats it differently for us, right? Down here, printed as a sort of formatted print thing. It's also got this sort of blue text for like, hey, you didn't tell me to print anything, so I assume you're just using me as a calculator, so whatever the result of your operation was, I'll show you on the screen. You're welcome, right? So writing code down here in the shell is actually exactly the same as writing out a number of lines of code up here, up in your sort of programming space. And what's cool about this is you can do things like use Python as a calculator. Like, for example, I could say my height in centimeters times, what's our multiplicative factor? Divided by 2.54 centimeters per inch, right? And if I do that, I'm 68 inches tall. And I can say print 175 divided by 2.54. Well, we could get into more fancy math functions, but that would say I'm 6 foot 8.8 inches tall, which is actually spot on the money, which I feel good. Testing is nice. Also, stopping the run at the error is nice. Yeah, it's a super, super handy thing. And what's cool about this feature is it's, I use it a lot for doing math like this, like using it as a calculator. But it's also a really easy way to test a piece of Python code, sort of in a very interactive way. You'll hear this referred to as interactive mode in a lot of editors and environments, where sort of you do a thing and then the program hands you the result back, and you do another thing and it hands you the result back, and that's really handy. You can also use variables down here in the shell. So for example, let's say rather than just like calculating this value, I assigned it to a variable so I could do something with it. Another little shortcut, if you hit the up arrow key, it will bring you back what you previously had on your last line of the shell. So rather than retyping 175 divided by 2.54, I just hit the up arrow and it brings it back into the shell for me. And this time, why don't I assign it to a variable? And I'll say h for height equals such and such. And you'll see, because I've made this an expression now, I've sort of done something, I'm not just like throwing math at it, it hasn't bothered to print out what I've done. It says, okay, I'll assign it to a variable h, but you didn't tell me to print it, so I'm not going to do anything. So now if I say print h, I get the answer that I was expecting, right? So I'm sort of writing a piece of Python code, a Python program, one line at a time, and having it evaluate for me one line at a time. So now I could say, let's see, print my height in inches is plus string h, right? And now it prints out the various number of strings. Does it only hold those variables while Thonny is open? Yes. Yes. So as soon as you close this up, your variables that are held within the shell, kind of like the variables that are held within each run of a program, will be lost essentially. And I think this is true. Actually, let's find out together. You'll notice I used the variable h down here. I believe because I ran this program earlier, the variables my name and my height should still be available in the shell. So let's try print my name, Jeff Glass. And that's because the last time I ran my code, it was Jeff Glass. Now if I say my name is JJGG, it will let me do that, right? Again, I didn't ask it to print anything, so it'll swallow that. And now if I say, using the up arrow, print my name is JJGG. Right? But of course, if I were to run this code again, the very first line clobbers that again, says, okay, well, this variable my name, which you had set at one point, we're going to set that right back to Jeff Glass, right? So print that again. And again, so that variable gets set right back to that. Palmer says, can you copy and paste a chunk of code from above? I think so. Let's find out. If I copy that and paste that, yeah, should be just fine. We copy this in, paste this in, and run that, and it prints just fine. Yeah, so if you were not quite exactly sure what a piece of code was doing, this would be a really easy way to test it. And of course, the print statement is relatively transparent about what it's doing, right? It's designed to be. But if you had some bit of code or functions that were doing something more complicated, this can be really helpful, especially if, and Palmer, you're leading me to a good point, right? Let's say I wasn't exactly sure how this statement was interacting with my variables, right? I could say, I could start setting my variables down here in the shell, right? So I could say my name equals Chris, my height equals 1,000 centimeters tall, and then I could paste in my bit of code from above, and because I haven't run any other bits of code that would contradict this, my name and my height in this context should be Chris and 10 meters tall. Oops, what have I done here? Operand types for string. Okay. So this is interesting. So my height should have been a number, right? Because I'm going to divide it by something, and I accidentally made it a string. So I've thrown an error here because it tried to divide a string by a number, and that's not allowed. So let's go back to my height. We'll make it a number, make it 1,000 centimeters tall as a number again. And now we'll run our piece of code. And hello, my name is Chris, and I am 10 meters tall. There you go. Chris, I haven't seen you in person in a while. I assume that during quarantine that, like, most people are not sort of stretching. But, I don't want to assume. So a really cool functionality having this interactive mode down at the bottom here. And a really easy way, if you're implementing or playing around with a new function, rather than trying to figure out, like, just writing a bit of dummy code to play with it, you can always do it down in the shell here, which is really neat. And it really is like, here, let me do a demo. So right now I will say my variable x equals 1, right? We'll store that there. And to your question, Chris, I'm going to close Thonny, and I'll restart it from my pie menu. And now, I think, if I do print x, it should say x is not defined, right? It says, I forgot everything you told me last time. I have no variable called x. Yeah, maybe more horizontal, more lying down is sort of, you're oozing, Chris, which you might want to see a doctor about. Anyway, so that's the shell. We'll make use of that a few times tonight, I imagine, but it's a really cool tool for, like, playing out with Python. Questions, comments, issues, concerns? You guys have been good about asking questions so far, so I'll just keep charging ahead, and you stop me. Oops, come on, stream controller, you were doing so good. Hang on, I'll reboot the thing. It might be because the Stream Deck app works over Wi-Fi, and here in my office I have a Wi-Fi extender, which I think it's a little bit grumpy about. So I'm gonna try and restart Bonjour one more time. We'll see if it comes back to life, but if not, we'll just soldier on. So, right now we're sort of writing our programs, more or less by hand. We're assigning values to variables by typing them into either the program or to the shell, and that's fine, but not terribly interactive. So let's introduce a new function that makes our programs a little bit more interactive. This function called input, which asks the user to input something, and you can put a string inside of the parentheses to sort of prompt the user for what you want. So let's make some modifications to our program to make it a little bit more interactive here. So rather than assigning my name and my height is sort of in the code here, I'm going to say instead my name equals input, what is your name? And then my height, I will do the same. I'll say input, what is your height? Right? And I will say, and I probably should say in centimeters. Right? So now when I run this code, you'll see down in the shell section, I'll run that. And rather than terminating, it just says, what is your name? And it leaves me with a blinking cursor to indicate that I'm supposed to type something here. So I'll say my name is Jeff Glass. I hit enter, right? What is your height in centimeters? 175, right? And now I get an error, right? Because I entered my height as a number, but the input function always returns a string. Right? No matter what I do, this will come in as text. So really what I'd like to do is right after this number is input, I would like to say my height equals int my height. Int is kind of like the reverse of string. It says take this thing, and if it's a number already, great, don't change it. If it's a string, I want you to turn it into the numerical equivalent of that string, right? So I'm going to enter the numbers, the digits of the word 175, so to speak, but what I really want is the thing that represents the number 175. Make sense? Let's try that again. So, what is my name? My name is Jeff Glass. What is your height? 175. Hello, my name is Jeff Glass, and my height is 175, or 1.75 meters. Very good. So now we sort of have a way of ingesting some input from the user, and along the way prompting them for what they should be typing in. You'll notice that the space after the input is sort of automatically put in for you, which is nice. And that no matter what you do, this input is coming back as a string. So if you want it as a number, you have to sort of cast it to a number. We talked about casting back in Arduino episode something or other. Casting is just the term for this piece of data that you have in what I know to be one format. I'd actually like if the programming language, to think of it in this other format. So you have a string. I'd actually like you to interpret it, to think of it as an integer, a number in this case. Similarly, down here when we're saying, take the string of my height, it says, hey, I know this is a number, but for the sake of this operation, I want you to think of it as a string, as just text that we can print to the screen. So the general term for reinterpreting what the type of some data or variable is called casting. So we're casting my height to an integer, we're casting my height as a string, and so on. Just a little piece of terminology for you. Cool? Oh, this poor stream controller. It's so off and on. I suppose surrounding it with even more electronic noise from this extra monitor is probably not helping it out any. Let's come over here. There's really is not a whole lot of point for me to have this this tabletop camera view today. I guess I don't know what this view is. You're over here now. There's no reason to have a keyboard view. You can see my tasty beer as I take a sip of it, but it's it's a little. Everything we're gonna be doing today is digital. So. But soon we'll be coming back to inputs and outputs from the Pi itself, which I know was one of the cool things we talked about last week from the Pi, is in addition to being a thing you can program on, you can control LEDs and switches and motors and things from that. So that will not be this week's topic. This week I just want to set up the framework for how you work in Python with some basic functions. Hopefully give you the chance to play around with this a little bit this week if you want to, and we'll jump into some I/O stuff next week or the week after, just so you know. So the input function, super helpful for prompting for input. Let's see here. The shell we already talked about. Int executes commands in order as if you were sort of typing them line after line in a piece of program. Results are printed automatically if you don't have a print statement. Super useful thing. Go in and play around with it. It's really awesome. Let's talk a little about conditional statements. As I burp into my hand. the first of our control structures for deciding whether we should do something or not. This should be familiar if you've been working in any other programming language. Basically, it takes some statement and evaluates whether it is true or false. In a numerical sense, we have greater than, less than, or equals to. We also have greater than or equals to, less than or equals to. And I also realize there's one I'm missing in here. For the sake of posterity, it is not equal to. That is the same as in C. It is exclamation point equals, means not equals to. Here's some little info about like how strings evaluate to be true or not. That's a little bit overkill. But let's just as usual, like I say, we're not going to spend a whole lot of time on the slides. I'd rather just jump over to the code. I'll start a new program so we can mess with this here. Let's call this piece of code. We'll call this authentication. And you'll notice that the suffix for a Python file is .py. That's across all systems. So this is going to be authentication.py or .py. Right? So this bit of code is going to be a sort of a swordfish level security device that only allows me access to critical information. So here's how this code is going to work. It's going to say name equals input. What is your name? Question mark. I'm going to say if name is Jeff, print your bank password is 12345678990, right? Else print go away, right? So let's run this bit of code and let's break it down just a little bit. So I'll run that code. It's gonna say, what is my name? If I say my name is Jeff, it says go away. I must have goofed something up here. Let's see. Equals Jeff. Let's see, Jeff. Aha, there we go. So, I know what I did there. So, so let's break down this code just a little bit here. Oh, here I'll show you it failing as well. Run that code again. What is your name? It is Lee. It says go away. Tremendous. Right, so there's some very simple parts of this code. The input statement we already know, so I capture the user's input as a name, and then I have my if statement, and then I have my which it says if the following is true, then do the next thing. And some bits of formatting to notice here. In Python, you can just start after your if statement, you put a space, and then you start typing your conditional statement. You don't need brackets or parentheses or anything like that. You do need a colon to follow it that indicates, you know, I'm done with this statement and I'm moving on to the thing that should be sort of conditionally happening. And in Python, your blocks, you know, how we know which parts of this code are sort of subservient to this if statement are indicated by indentation, right? So if you remember, if you know Arduino or C or anything like that, brackets would be the thing that you use to delineate what's inside of an if statement or not. In Python, what you use is white space, is indentation like this. So just to show you that, if I do print, we'll set up our code like this, right? So I say if name equals Jeff, then print your bank password is 12345, etc. And I notice this is indented here, which means this is underneath this if statement. But this statement, which is not indented, is not. So no matter what my name is, I'm also going to print also hello, right? So let me show you that, right? If my name is Jeff, right, then this evaluates to true. It is true that this name variable equals Jeff. I want to print this out, and then afterward I print also hello. But if I run this code again, and I say my name is Bob, right, I still go to this print statement here. You can see this print statement is sort of outside of the control of this if statement because it is not indented. So white space and indentation is really important in Python. It tells you what things are sort of captured into which blocks. I also threw in another thing here, which is the else statement. The else statement is what happens if this is not true. So since my name is Jeff, I would do this print statement. If my name is anything else, if this statement is not true, if my name is not Jeff, then I could say print go away and say the name of the person. And maybe afterward an exclamation point. Go away name, go away plus name plus exclamation point, just to really drive it home. We can get rid of this. Right, so if I run this code and my name is Jeff, it gives me my bank password. That's great. If I run this code and say my name is Eric, it says, go away, Eric. No bank password for you. Right? So the if statement sort of evaluates the truthiness of this equivalency. And if it is true, it does something inside the if statement. If it is false, it goes away. Case sensitive on the input? Yes, definitely, Chris. And I'll show you that. So I say, what is your name? My name is lowercase Jeff. It says, go away, lowercase Jeff. String comparisons in Python are always case sensitive. Now, one thing you could do if you, and going off script a little bit, one thing you could do if you didn't want this to be case sensitive, and this is not entirely internationalizable, is like if you, and this will probably not be a problem that you encounter very much, but like this method I'm about to show you does break in certain languages like Turkish. What you can do is name.toLower, which says, hey, take this string and give me the lowercase equivalent, and I'll compare that to the lowercase equivalent of my target. There's a decent chance I've typoed this, but let's see. So if I say my name is capital Jeff, .toLower, let's see, all lowercase, probably. This is one of those things that I would normally, I probably would Google. Is it just lower? Jeff, capital Jeff. There we go. So like I said at the beginning, like constantly looking at the reference and Googling what the functions are is just part of this. It took me 3 tries to get that right. And if it had taken me a 4th, we would have gone to Google and figured it out together. So you can use this lower method, which gives you the lowercase version of your string. You can say, okay, if the lowercase version of my string matches lowercase Jeff, then this must be the right person. You see, in this case, I typed in uppercase Jeff, and it gave me back. It let me into Jeff's bank password. And I could do the same, with all caps Jeff, and because it's only comparing the lowercase version of this to my name, then it's giving me access. So that's one way you could do it. There's also an upper version. You could do that as well, which basically converts any string to its uppercase equivalent. And same thing. The reason, so little sidebar, the reason that this breaks in some languages, this was actually, I read this today or yesterday, a really interesting piece about how in Turkish there are different forms of what is essentially, to my eyes, the letter I. There's what looks like a lowercase I without a dot, a lowercase I with a dot, an uppercase I without a dot, and an uppercase I with a dot. And so, in what we would think of as English, lowercase I dot upper, right? So lowercase I uppercased becomes, and I can't type it, is not equal to uppercase I. It's uppercase I with a dot, and uppercase I without a dot, lowercase I without a dot. So this kind of like basic comparison is actually breaks for some international languages. Oh, you can't see the code. Let me show you here. I'm sorry, broken thing. Right. So, there's like 4 different forms of I, so you can't just uppercase and lowercase things. There are provisions for basically dealing with international languages that make you specify either what language you're working in, or just like a general international language, which is essentially American English. But in any case, for our purposes, working mostly in English, upper and lower will do just fine. Good question, Chris. So yes, upper and lower are ways to deal with case insensitive input. Let's see here. Maybe reset this again. And let's see what's next. Chris, I love a good tangent. Let's see what we've got here. See, it's funny. Chat used to be here, and now it's here, and it's driving me. It's making me a little bit wild. Next tangent. Referencing back to, can you pull a specific character from an input? If character 3 is F, Chris, you totally can do that. It is definitely applicable. It's going to be a little bit more applicable in just a little bit. I love it. You're thinking along the same lines I am as to what we're going to talk about tonight. But before we get there, I want to talk about a couple other real quick things, I think, which were, this is actually just going to lead in really smoothly. I like it a lot. So we've looked at a couple different kinds of variables already, like strings and numbers. Real cool. There are various ways of encapsulating these structures into data structures, variables packed into data structures. You remember, if you were around for Arduinos, and that I know Chris and Palmer, who are in the chat, were around for the Arduino section. We talked about arrays a lot, sequences of variables put together into a structured list. Python has some similar structures and actually has some more advanced structures which make our lives easier for doing certain tasks. But the most simple structure that it has is the list, which is just a list of stuff, numbers or strings or other lists or objects. The way you instantiate it is with a list of entries separated by commas between square brackets. So let me show you what that looks like. Again, I told you, like I think it's more interesting to see the code in the screen than on the slide. The slides you can always download if you want to look at those examples, but these ones are going to be better. So let's create a new list called myList, and we'll say it is equal to open square brackets, and it's important that it is a square bracket. 1, 2, 3, 4, 5. Actually, let's start from 0. Let's do 0, 1, 2, 3, 4, 5. Right? That's a piece of code that runs. It doesn't do anything yet. Oh, it's going to make me save it. I'm going to call this my list demo. We'll save that. And I run that, and of course nothing happens. But now that I have my objects stored in a list, I can start referencing them. And the way that you reference them will look very familiar if you were doing Arduino code. You can access a specific element of a list using the square brackets following the name of the list. So for example, I could say print, let's print this out, print myList at index 2. And just like in C in Arduino, lists are indexed from 0. So this 0 here is in position 0. This 1 is in position 1, position 2, position 3, position 4, and so on. So lists are always 0 index. So the 0th item of a list, if I run this code, should be 0, right? The 4th item of this list, which is not an accident that I started this list from 0, the 4th item is 4, right? So lists don't have to contain just numbers. They can also contain strings. I could say my list contains Jeff, Palmer, and Chris, right? And if I say print myList 1, what should it print? Well, the 0th item of our list is Jeff. The 1th item, the first item, I guess, of our list is Palmer. So this should print Palmer. Piece of cake, right? Lists don't have to only contain one kind of object. It'd be a little bit strange, possibly, if you were building a program to do something for this to be the case, but just so you know it's possible. I could say my list contains, instead of Jeff, Palmer, Chris, it could contain 47 Palmer, 103 Chris. And now if I print the first item of my list, it's still Palmer. If I print the second of my list, it's the number 103, and so on. You can also have... Do spaces matter in lists, Palmer? No, they don't. It's a matter of style, if nothing else. But things will work just as well without the spaces. Good. It's a really excellent question, given how much I harped on about like white space mattering for indentation. Indentation matters as far as blocks. White space within a line usually doesn't, but we should try and catch when it does. It's a really good catch. So I'm going to put those spaces back in just because I like the way that formats out, but you don't have to. Really simple. A list is a collection of items specified inside of square brackets that you can access a specific item of using this syntax. Lists can also contain other lists. So here, I'll show you. So I can print an individual item of a list or the whole list, right? So if I just say print my list, Python is smart enough to say print all of the items of it for me. It knows how to take in a list and print it out, which is really handy, right? So I could have this list be 47 Palmer, 103 Chris, and how about another list inside of square brackets, which is going to have the names Jeff and Glass, right? So you see here I have this list, and it's the 4th index of my larger list. So if I print my list 4, I should get the smaller list, Jeff and Glass. And this is actually a pretty common thing to do to nest data structures in this way. You can imagine a situation, and I'm not going to put your actual names here, but I could have a list of lists that said was a list of first name and last name. So Palmer, J, and then comma, and then Chris and W. I guess your last names are in the chat. I guess, Chris, at least your last name is in the chat. So it's not like it's super hyper secret or anything. But now if I print out, say, the 0th item of this list, I get the smaller list, Palmer J. If I print the 1th item of this list, I get Chris W, and so on, right? So the objects in the list can be any object, whether that's a variable or another list, or another of one of the data structures that we're going to talk about in a second here. But to illustrate a few more cool things about lists, let's go back to a slightly simpler one. How about apple, banana, carrot, and what's a food that starts with a D? A dapple. You can tell I'm making this example up as we go, right? So if I print item 1 of my list, I get banana. Can you get just the W out of that sublist? Oh, good question, Chris. Yes. Here, let me copy this, and then we'll undo back to that example. In the meantime, I'll think of a food that starts with a D. Oh, man. Okay, so back to our list that has lists within lists, right? So let's say Chris wanted to know if I could access just the W out of the list that includes Chris W here, right? So to get the Chris W, I do my list index 1, right? Because the first object is this small list. The second object is this small list, so it's index 1. Right, so I get Chris W. So if this represents the small list Chris W, the way that I get the number 1 index of that list is just to put brackets 1 after it, right? So if this is, again, this is Chris W, then the 1th index, the number 1 index of that list is W. So when I run this, I should get just W. Does that make sense? So you start from the sort of beginning of your data structure here and say, okay, what does this actually represent? Okay, my list 1 is Chris W. Okay, I've got that object back. Now what do I do with it? Oh, I'm supposed to look at the number 1 index of that list. Oh, and that's going to be just this W here, if that makes sense. Palmer says, would those lists work without the quotation marks? Palmer, no. So the quotation marks are critical in that they're telling Python in this case that these are strings that I want it to represent. If I don't, it's going to assume that they are the names of variables. So right now, this is saying this small list is the string Palmer followed by the variable J. Here, in fact, let's do a slightly simpler example that'll illustrate this. I'll say my list equals oh god, I can't do dapple again. I'm gonna look at things that I'm seeing around the room. Screwdriver, laptop, and pencils are just things that I have here. If I print the 0th element of that list, it's a screwdriver. If I take the quotes away, Python's going to look for a variable called screwdriver, and it's going to throw me up an error saying, you haven't defined a variable called screwdriver. Donuts. Thank you, Chris. Donuts. Let's keep that. Now, of course, Palmer, I could make a variable called screwdriver. I'd say screwdriver is a variable that represents the number of screwdrivers that I can see from this position at my workbench, which is about 18. Right? So if I do that, then this list now contains the variable screwdriver and the string laptop and the string pencils. So when I say print my list 0, it's going to say, okay, I'm going to print out this variable. What's the value of that variable? Oh, it's 18. So this should just print 18. Let's see. Is there a way to print the outputs without the quotes? I'm sure it's a decent tangent. I'm not quite sure I understand your question, Palmer. Only so that when you're defining a bit of text, like the laptop or pencils, you're always going to have quotes somewhere, just to indicate that is a bit of text. Even if up here, like let's say this variable was just called S and it represented the string screwdriver, right? So now when I try and print the 0th element of my list, which is the variable S, which represents the string screwdriver, I still had to put the quotes up here, if that makes sense, which is just the string screwdriver. Make sense? To display Palmer J without the quotes, oh, I see. Yeah, so we're talking about, I think, get rid of this hardware list, right? So going back to this, I have the list output Palmer, quote J. Yeah, okay, I gotcha. So what's happening here is that it's printing this whole list. Like if I print out my list, no brackets after it, and I run it, it's going to print basically everything that it knows about inside of this list. If I print the 0th element, it prints the small list consisting of just Palmer and J. And what I think, Palmer would like it to print out is Palmer J. Right? Like that. Yeah? So there's a couple of ways you could do that. One would be here's sort of the manual way. So Chris has got the example in the chat, but just to type it out interactively here. If you knew this was a list of 2 elements, you could say print mylist 00 plus print mylist 01 gives you Palmer J, right? So mylist 0 is this little list called Palmer, comma J. We'll print the 0th element of that, which is Palmer, and the 1th element of that, which is J. That'd be one way to do it. Let's see. The other way you could do it in Python, just to show you, and I'll see if I can remember the syntax off the top of my head, is I think this. Let me make sure this runs, and then I'll explain it a little here. Nah, I screwed it up. Oh, I'm missing parentheses. Yeah, So you can use, if you want to just concatenate all of these strings in a list together, you can use this join function, which just joins everything together. In fact, I could run this on the whole list if I wanted to. Oh, but it's got lists. Yeah, that's right. Which just smashes them together as Palmer J, but it doesn't add the space in between. There is a syntax where you can like add intermediate characters, but to be honest, I'd have to Google it. Yes, yeah, Palmer. Chris says you need to put the space in there automatically. There's also no reason why you couldn't like reference these to 2 different things. Like you could be mylist 00 and mylist 2, and list 2 is of course this one over here, Jeff Glass. So you could be Palmer Glass. Don't tell Katie; it'll be fine. So yeah, so you end up needing to sort of get the individual elements that you're interested in out and print them one by one. And I'm sure there are shorter ways to do that. One of the things that we'll find as we go through, and tonight I want to keep things just a little bit simple, but especially when you're working with these built-in data structures like lists and a couple of the others we're going to look at, there are often sort of shortcutty ways to do things. Built-in functions that help you, do things like smush all the elements of the list together into a string, or build a list of numbers very quickly, because that's a thing we might often want to do. Speaking of building lists of things quite quickly, let me see here. Okay, before I get there, a couple other things to say. I'm getting ahead of myself, and I will come back to your question, Chris, about how to get just a specific letter out of a word, for example. So let's make a slightly longer list. Did I save this? Yeah. Thank you, Chris, for replacing Dapple. Hang on, I need a beer break just to sort of like live down the shame of Dapple. Okay, so we have this list, and let's add one more. Eggplant is a good one. All right, so we have a list of 5 things. So it would be egg's also good. It'd be nice if we could access not just the individual element from a list, right? So my list 1 is going to be banana, but sometimes we want to access sort of a range of elements from a list, right? So it might be that we want to access, say, the first 3 elements out of this list: apple, banana, carrot, and make ourselves a little list that is just those elements. There's a shorthand syntax for that, and it looks like this. Inside of our square brackets here, where we're referencing what elements we want, we can put 2 numbers separated by a colon. The first number is the index we'd like to start at. So in this case, let's say we want to start with index 0. The last index is the first element we want to exclude, right? So in this case, I'm going to get elements 0, 1, and 2, but not element 3, right? So 0, 1, 2, and not 3. So in this case, if I do my list 0 through 3, I should get, when I run that code, a list consisting only of apple, banana, and carrot. Yeah? If I were to do, say, list 2 and 5, right? And you'll notice that 5 is beyond the end of my list. So I have element 0, 1, so 2. So the first one will be caret, 3, 4, and we won't include element 5, but that's fine because there is no element 5. When I run that, I get carrot, donuts, eggplant, right? Elements 2, 3, and 4. Some little shorthand here that can be nice. If you, let's go back to our 0, 3 example. If you omit the first number, it assumes it means you want to start from the beginning of the list. So my list 0, 3 is the same as my list just colon 3. It says, I'm not going to bother giving you a start index. Please start from the beginning, right? So those two lists come out being the same. Going to our other example, if I print my list, say 2, and omit the second argument, that is the same as saying just go to the end of the list. I don't know. I don't want to figure out how long my list is. Just give me the end of the list, right? And it will execute if I type it incorrectly. I hope. Print my list 2. Oh, also that. There we go. So we'll see carrot, donuts, eggplant, carrot, donuts, eggplant, right? So I can omit one or the other, and it'll automatically start from the beginning of the list, or it'll end at the end of the list. And that's often a really handy thing to do, because often what we want is just like the first few things or the last few things. What happens if I do 2, 6? Nothing. It'll anything that it doesn't have in its list, it will just sort of ignore. But that assumes that there are any valid elements. So if I say my list 5, 7, I actually just get an empty list. It says, hey, starting from element 5 through element 7, do you have anything? No. Return an empty list, which is not the same as nothing, so to speak. It's just a list with nothing in it, if that makes sense. So that's kind of that's a little handy shorthand for taking little snippets and individual elements of a list. This is a little bit deeper, but just a really useful syntax. Often what you want to do is say, get the last element of a list. So there are a couple of different ways you could do that. You can imagine, if you were taking attendance in this program, and every time somebody came in, you typed their name into an input statement and it added them onto a list. And then later on, you're playing a game with your class, and you want to pick on the person who showed up the latest. You want to get the last addition to that list. There's a couple of different things you could do. One is use a built-in function called len, which just gets the number of elements in a list. Right? So I could say length of my list with the name of a variable equals len my list, right? And if I print out, length of my, this is an awful name for a variable because it's just so long, but if I print out the value of that variable, I see that there are 5 elements in my list. So I could do one of two things. If I wanted to get the last element of my list, I could say print my list length, I even spelled it wrong, length of my list minus 1, right? Because the last element of my list is going to be not element 5, because we count from 0, so 0, 1, 2, 3, 4, right? So that should get me eggplant. So that's one way that I could reference the last element of my list. I could get the length of it and then go back 1. But there's a bit of shorthand we can do here. I can also, if element 0, say, is the first element of my list, element 1, element 2, element 3, and so on. If element 0 is the first element, element -1 wraps around and is just the end of my list. Element -2 is the second from the last, and so on. So if I want the last element of my list, I can just say my list indexed at -1, -2, and so on. So this is a really handy way of getting a single thing or multiple things from the end of a list, which is often kind of a handy place to be. We can combine this with our colon syntax from earlier and say, hey, I want the last 3 elements of my list, but I don't really want to bother figuring out how long the list is. I just want the last 3 elements. So I could say, I want elements from -3 of my list through the end of my list, right? So it's going to go to the end of my list, count 1, 2, 3 back. That'll be the first element I look at. And then I haven't given it a second argument here, so just go to the end of my list and you figure it out. Right, and I want to format that correctly, and we'll see it gives me carrot, donuts, eggplant for the 1, 2, 3 last elements of our list. And we could combine this with our earlier syntax, right? I could say, give me -3 through -1 not inclusive, so just carrots and donuts. So -3 and -2, but not -1, and so on. Chris says, could you add the -1 to the variable? Yes, you certainly could. Yeah, you could. So you could do -1 up here. That would be another way to do it. This len function, knowing how many items are in your list, is useful for a lot of things. But in the case where you're just sort of pulling objects out of a list, this is a really convenient syntax, because a lot of the time what you want is like the first element or the last element, or the last 3 elements or something like that. So that's a little handy shorthand for us to use. Restarting the stream controller is going to be kind of the refrain of the night. There we go. So this all leads me back around to a question that Chris asked earlier, which is, could you, say in an if statement, match on just a singular letter of a word? And yes, you can. And I wish I had constructed this a little bit more cleverly so I'd have a good example. Oh, here's a good one. Let me get rid of this. We'll continue using our list of excellent ingredients here. And here's the condition I'd like to do. I'll just write it out in English and then show you in text. Let's say if the third letter of the ingredient is N, and then otherwise do something, print, this is a good ingredient. We'll say that we're some kind of capricious eater where the only foods we want to eat have their third letter as an N. If the third letter is not N, then we hate it very much. We're sometimes like the world's worst toddler. We're just not going to eat anything that doesn't have N as its third letter. And you'll see I've made that up on the spot because that should match banana and donuts, but not apple or carrot or eggplant. So I'm glad that there's some common letters in there. Very clever, totally planned. So here's how you would do that in Python. Chris agrees. Yes, I mean, are we really banana and donuts? Yes, I would eat apples and carrots, but as a toddler, maybe just bananas and donuts. This might just be me. So here's what you could do. So let's see. So how are we going to do this for our list? We haven't covered how you walk through lists yet. So let's do this with an input statement instead. So let's say input. Toddler grumpy, give me food. I should be consistent in my use of quotes, single or double quotes. Give me food, and I'm going to assign that to a variable called food. So I'm going to ask the user for input because our toddler is grumpy. And then I'm going to create an if statement here that says if food brackets 2 equals lowercase n, do something. Else, do this other thing. So the thrust of this is here, Chris, and friends, and everyone else, you can index strings just as if they were lists, right? So this notation says if the tooth index, the number 2 index of our string is lowercase n, we'll get back a good ingredient. Otherwise, it'll be a bad ingredient. So let's test that out. I run my code, it says, toddler grumpy, give me food. How about an apple? That's a bad ingredient. Let's run it again. How about a carrot? That's a bad ingredient. How about a donut? That's a good ingredient. In fact, let's have this print out. What the food is in our name here. So we'll say, instead of this is a good ingredient, we'll say food plus. Remember to include the space in the string that we write. And then down here in this print, we'll say food plus is a bad ingredient, just so we have a reminder of what we had entered for, right? So if I run this code, I say banana. Banana is a good ingredient. Eggplant is a bad ingredient, right? So this is one way of picking individual characters out of a string. So another thing you can do, and I may have to double check the syntax on this, I told you I would do it often, is rather than saying if a specific letter matches a specific position, you could say if a letter is in the string itself, right? If the food now contains an N, it will be a good food. So in this case, apple and carrot should still be bad, banana and donuts should still be good, but eggplant should now also be good. So let's double check that, right? So apple does not contain an N, but banana is a good ingredient. Run it again, carrot. Carrot is bad, but eggplant is now good. So we have this new operator, this in operator, which basically says if the first thing is a member of this list, to be perfectly honest, and strings act a lot like lists here, we can use that as part of a conditional. If this thing is in this list, then this is all true. right? So I could also, this is doing this example with a string. Let's do it with a list, right? So let's bring back our list of foods here: apple, banana, carrot, donuts, eggplant. And let me say, I will still ask the grumpy toddler will still demand some food, and let's say that this list is now the only foods that our toddler will eat: apple, banana, carrot, donuts, eggplant. This is a weird baby, no, not gonna lie, but a healthy baby, more or less, other than the donuts. So here's what I'm gonna do. I'm gonna ask my toddler was gonna demand some food, and I'm gonna say if the food is in my list, then I'm going to say food is a thing I like. And if it's not in our list, I'll say food is a thing I hate. Because he's a baby and he's very dramatic, right? So now when I run this code, I say, toddler grumpy, give me food. And if I say apple, apple is in my list. This apple value is in my list. So this is true, right? If I run that code again and I say cake, which you'd think a baby would like, cake is a thing the baby hates because cake is not in the list. That sort of makes sense? So this in operator is a really easy way of checking whether an object is in a list. And this comparison works a lot like the equals comparator in that it is, to your point earlier, Chris, case sensitive. It is also cake sensitive in this case, right? So if I say, earlier we saw with the baby liked capital A apple, it will not like lowercase a apple because it does not match. Now there are ways around this, of course, like earlier, right? If I make my list canonically lowercase, right? Carrots, donuts, eggplant, and I take my input as food. I could also say if food dot lower, right? The lowercase version of my input is in my list, then apply it, right? So now I could say apple, right? And screw up the capitalization that way. But now apple is still a thing that the baby likes because the lowercase version of it is in the list. Make sense? Question? The in operator, the looking for something in a list, is super, super duper useful. You can reverse this. You can use the not operator, right? So the same way that we have a not equal, we can say if food is not in my list. So now this is a list of things, the only things in the world that this baby hates, right? So if I say apple is... so the only things the baby will like are things that are not in this list. So because food.lower was in our list, this was false. So we go down to apple being a thing that the baby hates. We have this not operator, which is the opposite of the in operator, if that sort of makes sense. Yeah? I know we're going... I feel like we're going kind of fast tonight, but partly because I think Python is fairly intuitive in this way. I confess I do often have to Google, like, what exactly is it, square brackets or is it curly brackets? And that's just part of it. You just end up Googling these things, or looking them up in the reference or the tutorial. But it's all relatively intuitive, I would say, and kind of fun to work with. And the fact that you can treat a string like a list is pretty cool. Gives you easy ways to like slice and dice strings and do things with them. Yeah, nifty. Keep coming with the questions if you got them, but I'm just going to keep plowing ahead. So we talked about indexing strings with brackets, sub-indexing with brackets and colons, using the in operator we just talked about, right? So if the object Jeff is in Jeff or glass, but 90 minutes is not in the list of vocabulary, so that's false, let's say. Oh, here's a few other things we should talk about, and again, I'm just gonna do them in the code. So let's see here. Let's get rid of this example, and we'll get rid of the toddler's voice here. Some more things that you can do with lists. Let's say you have a list of things, and you have another list of things. My second list equals donuts and eggplant. I can say my big list equals my list plus my second list. Print my big list, right? When I run this, we'll see that it has just taken these two lists and smashed them together end to end, the second one after the first, right? We're using this plus operator for a lot of things, but depending on context, Python can usually figure out what you mean to do. And of course, if I reverse the order of these, all right, say my second list plus my list, we'll see that we now have donuts, eggplant, apple, banana, carrot. Donuts, eggplant, apple, banana, carrot. Right? Just smashing those two lists together, a super easy thing to do. Another thing you might want to do with a list, and again, I know we're kind of flying, but these are, I don't know what I'm trying to excuse. These are sort of some basic functions, and as you're playing around with these, I guess here's the point. Like, I know we're going kind of fast. What I encourage you to do is play around and write some programs. Write a program that has a list of foods you like and looks up your input in them. Write a program that calculates your body mass index given your weight and height, or a weight and height of your choosing, if you so prefer, and then stores them in a list associated with your name, and then brings them back to you. Like, that's really the best way to learn this kind of stuff. Anyway, another thing you might want to do is add something to a list at some point in your program. So, for example, let's say I have my list of ingredients here. And let's say I want to print it out, and so far it's just apple, banana, carrot. But a thing you might want to do is add something to that list. So let's say I'll create a variable called addition equals input. Please give me a new food, right? And to add that new item to the end of our list, I would use the append function. So mylist.append addition, right? And that's going to take whatever I give it and slap it on to the end of my list. Right, so I run that code. It says, please give me a new food. I'll say churros. Sounds good. And I print that whole list, and we'll see it's now apple, banana, carrot, and churros. That's a hearty breakfast right there. This is really useful because, often what you want to do is add additional items to the end, but because your last position is outside the end of your list, you need to sort of indicate that you want to make the list longer before you add it in. You could also, use index notation to change one of the items in a list. So in this case, once I've taken a new food, I could just say that the first item in my list, the item at index 0, is now going to be equal to that new thing I just got from the user, right? So it's going to replace apple with whatever I give it. So if I run this code, it says, please give me a new food. I'll say ice cream. And now we have ice cream, banana, carrot. So this brackets notation, that's how we got an object. It's the same thing for putting a new object in its place, right? So the 0 thing is now going to be assigned the value of this new variable. Can you append the input in all lowercase? Yeah, for sure. So there's a couple different ways you could do that. So let's undo this and go back to that example, right? So I could put the lower function here. I could say addition.lower, right? Let's show you that. So new food is going to be pizza, right? But of course, it's lowercased it before it's added it to our list, which is really nice. Basically, what it's done is it's taken this variable, which is addition, and here I'll print addition afterward, right? And it said I'm going to append something to my list. What's it going to be? The lowercase version of our addition variable, right? So even if I do capital pizza, right, the variable itself is still uppercase, but I've given a lowercase version of it to this list to append. So that would be one place you could do it. You could also, I think, let's find out if I mess this up. I think you could do the lowercasing here, right? Because this object is going to give us a string, and now we're going to make it a lowercase thing and make that the value of this variable, if that makes sense. So when I run this and say I like pizza, now the semantic difference here is that the variable itself is now a lowercase version of my input, and that's just being added to the list. Whereas above, this variable was exactly what I input, and we were just giving a lowercase copy of that to put into the list. I see the future, loop the input until it gets to a blank input. Could certainly do. Yeah, we'll talk about while loops tonight for sure. Yeah, we'll do lots of good things. So there's a couple different places you could put this lowercasing statement, and it sort of depends what you want to do with this variable, right? If you want to have a copy around of exactly what the user typed, but you want to have a list of the lowercase versions for comparison's sake or something, maybe you want to do your lowercasing here. And then maybe we want to have, user, I have another list called user entries. And let's say it's just an empty list to start. And every time the user enters something, I'll say user entries dot append addition, right? So now I'm going to keep a lowercase copy in this big list so I can compare things to it, and maybe I want to have a copy of everything that the user actually entered in case I want to print it back to them with exactly the uppercasing that they had, for example. Want to add 4 items to the list? Yeah, for sure. I think, Chris, you're again getting just a little bit ahead of me. I want to make sure we don't have too much. I might have a couple more things to say about lists. I might have a couple things to say about my stream controller, but, you know, you've heard those already. There we go. Hello again. Hi over here on this camera. Let's see here. What else do we have to say about lists? Oh, I've made this point already. Lists can hold numbers, strings, objects, or other lists. And here's that sub-index notation we looked at earlier. Strings are lists. We got there already. So it's going great. We're ahead of the slides, which is making me very happy. Yes, I want to talk about for loops before we get to while loops, and that's probably where we will end it for tonight. Just because we're on a true 90 minutes for once, and I think we can push on. There's only a couple more really fundamental things we should get through. So, and again, let's just look at this in the code. If my controller will ever let me get back there. Here we are. Start a new example here. So let's steal our list of delicious foods from this other example. I'm going to save this real quick. We'll call this the for example. So let's say I wanted to print all of the objects in this list one at a time, but I'm not sure in advance how many objects there are, right? If I know how many objects there are, sort of like earlier with Palmer, Chris says we lost the donuts. That's probably for the best, huh? I could do print my list. Let's do something a little bit more descriptive than my list. Let's call this foods, right? Print foods 0, close parentheses, print foods 1, and print foods 2, right? If I run that, I get apple, banana, carrot. Totally great. But this sort of assumes that I know how many foods are in my list before I run this code. And for this very simple example, that's easy, but you can imagine this either being a much longer list or a list that depended on what else was going on in my program, right? So having a programmatic way to step through all the elements of a list would be really helpful. Thankfully, as you might tell from this lead up and the slide we were looking at, we have exactly such a structure. It's called the for loop. Now, if you remember back to Arduino land, we also had for loops. And every for loop had an index, sort of had a number that sort of counted up or down or evaluated a statement, that sort of told us when we were done. Python has those too, but it has actually a cleaner way of iterating through loops that I want to start with. So rather than having to say have a number that counts from 0 to 1 to 2 and then stop, we can just say, hey, I want to pass through everything in this loop like this. For f in foods, print f. Now when I run that, I get apple, banana, carrot. Boom. So what this does is says, hey, for each element in the list foods, and whatever list you apply, assign the value of each sequential item in that list to a temporary variable. And this you can call whatever you want, right? You could call it temp, you could call it x, you could call it variables, right? Doesn't really matter what you call it. It's nice in a lot of cases to keep it a little bit short. I like to use the first letter of whatever my list is, or like I was writing a program recently where I was dealing with a big list of things called entities. So I had for ent in entities, do something inside of a list and so on. But it doesn't really matter as long as it's clear to you what it does. It just sort of sequentially assigns. Apple gets assigned to F, and we print apple. Then banana gets assigned to F, and we print banana. Then carrot gets assigned to F, and we print carrot. And then that's the end of our list, so we exit this loop. And once we're done, we can say print, we named all the foods, right? So in that case, we get apple, banana, carrot, we named all the foods, and so on. So a really easy way to step through a list without knowing how many members it has ahead of time, right? Apple, banana, carrot, donuts, we named all the foods. Totally great. Sometimes, though, it is handy to step through a list in a way that you know what sort of number of the list you're on. Let's do an example here. Let's say we wanted to print out some square numbers, all the squares of numbers from 1 to 10. Well, we could make a list of numbers from 1 to 10, but actually we have a faster way of generating just a simple range of numbers, and it looks like this. I could say for I, just a dummy variable, in range 0, 11. The range function, which again includes the first number but does not include the last number, generates a list of numbers starting at the first number and ending 1 before the last number. In this case, I would say print I squared. Remember, this double asterisk is the exponentiation symbol, right? So when I run this, I should get 1, 4, 9, 16, and so on up to 100. So this range statement is a really easy way of generating sort of indexes of numbers up to a certain value. Sometimes you'll see this written as this, right? Just to help imply that, like, hey, the number we're interested in is 10, and because of, range is not inclusive, I need to increase this by 1, right? So again, same thing. One way you might combine this with the previous idea of stepping through a list of objects or strings or names is to use these two concepts together, right? Let's say I want to step through each of these objects in this list, and I want to print out, say, 1 apple, 2 banana, 3 carrot, 4 donut, right? Let's say I like to have a nice ordered list and numbered by where things are in a list. So in that case, I could do for I in range 0 to the length of my list, right? So in this case, my length will be 4, which is 1 pass. So I have 0, 1, 2, 3. So I won't include the 4th object here, but there is no 4th object, so we're fine, right? So if I just print I, or let's go back. Oh yeah, let's use, so if I just print I, we're just going to get 0, 1, 2, 3. So really what I'd like to do is print I plus 1, right? Let's get our numbers printing, 1, 2, 3, 4. And since I want to print something after it, I'll print a space and then foods indexed by I, right? So now, each time I go through, right, I starts as 0. I'll print out 0 plus 1 is 1, a space, and then foods 0, which is apple. Then I becomes 1, so I'll print out 2, and then foods 1, which is banana, then food 3, and so on. So this is a really easy way if you have a need to later, say, refer to your items in your list by their index. This is a really easy way of stepping through your list in that way. There's also a built-in function called enumerate, which does this for you, but I think the syntax is a little bit confusing. So this is a really easy way to combine the range function with looping through a list, if that makes sense. Yeah. I should say the range function. Hey, let's go back to a previous example here. The range function can take. That took a while, huh? Donuts. Can take one more argument if you want it to. So in this case, right, it's taking 2 arguments. Starts at the first one, ends 1 before the last one. If you give it a 3rd argument, it is the step that you take between steps. So in this case, let's just print out, instead of printing our squares, we'll just print our numbers. And you'll see if we do range 0, 11, 2, rather than going 0, 1, 2, 3, 4, it goes 0, 2, 4, 8, 10. If we count up by 3s, we get 0, 3, 6, 9, and then because we're beyond the end of our range statement, then we just stop. So this is an easy way if you're counting through a list by some multiple of a number. You can use this range statement with an additional argument here. So that's a really handy thing. What did I want to talk about next? I feel like I had one more. I did want to do a couple more things. One of which is nerdy, 2 of which are practical. So let me do the nerdy. Let me do the really nerdy thing first, because I think that'll be a little bit easier to grok before it gets too late in the evening, and then we'll do 2 more practical kinds of one more practical kind of loop, 1 more data structure, and then we'll call it a night. So here's the nerdy thing. So I mentioned earlier that we wanted to talk about the difference between compiled and interpreted languages. And now I've advanced my slides on me here, but when we talked about Arduino-y stuff, we talked a little bit about the process of turning code that we write, which is essentially something like English, into ones and zeros that the electronics of the computer know what to do with, right? And this is a slide I totally stole from a previous lesson, in that we took some code, in this case an Arduino sketch, then we had to run a preprocessor on it to make it more formal code, then we had to use a compiler to turn it into assembly code, that turned into hex code, which is the literal ones and zeros that were going into the device. And then finally, in our case, onto an Arduino, we had to use a physical device programmer to sort of get that code from our computer into the device itself, right? And this whole process had to happen before the code on the Arduino even started running, right? So when you're uploading code to an Arduino, when you hit upload, you see it first, it compiles, and it figures out what everything means. It turns it all into these important ones and zeros, and once everything is kosher, then it pushes it out to the Arduino and it actually runs. That's an example of a compiled language. We're using a code compiler to, in advance, turn the English language code we've written into something that the machine can understand. That is different from a compiled language. Oh, sorry, from an interpreted language. And I think I've put some of these things out of order here, right? So a compiled language runs through a special program called the compiler before the code runs. The program turns the entire code base into a version the machine can understand. And here's some examples of compiled languages, right? Arduino code as we know it, which is basically C++. QBasic from back in the day on DOS is a compiled language typically. Go or Golang, which is the new hotness out of Google. Java, Rust, like a lot of popular compiled languages, right? That's in contrast to an interpreted language. An interpreted language is sort of the opposite, in that rather than ingesting all of the code at once, turning it into machine code, and only then, if it makes sense, running it, Python and other interpreted languages ingest your code one line at a time, run it, and only then ingest the next line of the code and run it. Languages like Python or Lisp or Ruby, or like the code that runs in MATLAB, are mostly interpreted. And that leads us to a couple of trade-offs. A compiled language is often going to be faster or more efficient or optimized because it can sort of look ahead through all the code and find efficiencies in how you've written things and sort of condense things for you. But of course, after you compile it, the ones and zeros that tell the electronics what to do really only make sense for one specific architecture of computer. So x86 versus an ARM processor, Windows versus Mac versus whatever flavor of Linux you're running. And if you want to run that code in a different environment, you may have to recompile your source code so that the ones and zeros that come out make sense for the system that you're using. In contrast, an interpreted language is often slower or maybe less efficient to run because, of course, it can only look at one line at a time, but it's much more portable in that my Python code running on my Python interpreter on my Raspberry Pi will also, that exact same Python code will run on any Python interpreter on a Windows machine or a Mac machine or another Linux machine. It's also what lets us do that cool thing that we saw earlier where we could run individual lines of code until something broke, right? If I come back to our original program here and I mess up the syntax in this last line, it will still run. Oh, well, if it can parse the file, let's see. Let's break. How do we break this earlier? We gave ourselves a string to divide instead of an integer, right? So it'll still run my program, right? It'll ask me my name. It'll ask me my height. It'll do my first statement, and only when it tries to ingest this last statement and run it will it throw an error and break. And that's a really cool functionality. And it makes it a lot easier to do some cool things that we haven't looked at yet, like debugging, which is really easy to do in Python. And we can do in Thonny like this. So rather than hit the run button at the top of the screen here to run this program, I'm going to hit the next button over called the debug button. And what that's going to do is say, hey, rather than trying to slam through as many lines you can at a time, I want manual control of when you go to the next line, right? So in our case, right, it would normally pause after this first line anyway, right? And let me input some input. But you'll see over here on the side, it's popped up this new window called variables, right? And it's highlighted 3 new buttons over here, over, into, and out. Those are for jumping into or out of blocks of code, right? You could jump into an if statement or out, or into a loop or out of it. If you just hit this into button, though, you will step through individual lines of code one at a time, right? So let's step through this program one little bit at a time. I'll say into. We'll see it's executed that line of code and asked me for my name. I'll say Jeff, right? Then it's paused before executing the next line of code, and it's showing me that the value of that variable called my name is Jeff. How cool is that? Do the next into, and I'll say I'm 175 centimeters tall. Hit enter. We'll see my height is now 175, right? It hasn't executed the next line yet. Now when I hit the into button, right, we can see that the value of my height changed from that string 175 into this string 1000. Right now, right, I click into in the next couple lines of code, and it prints out my name and my height. Then I hit execute, and it gives me an error. It says unsupported operand types. It gives me the error right on the line where it occurred, right? And if I was having some trouble understanding what was going on, now because I've stepped through this one line at a time, I could look over and see, oh, what is it going on? Oh, why is my height? Oh, my height is a string. Oh, that must be the problem. I can see the values of all of my variables in real time, which is super, super useful for troubleshooting this kind of thing. So debugging mode is a really useful functionality, and because Python executes one line at a time to start with, this is a really easy thing for the interpreter to do, and it's pretty much accurate. It's much more complicated in a compiled language because your compiler has to keep track of what line of code corresponds to what machine code at the end of the day. So play around with this debugger, play around with stepping into and out of code. Let's do it for another example here. Let's do this for this list demo. Here, we'll stop our previous instruction here. We'll come to list demo, and we'll debug it. All right, so we're writing our new program down here. We'll see before our first line, we have no variable set. We hit into, and we see we have a new variable called mylist, apple, banana, carrot, and we get a new user entries list, which is empty, right? I'll run my addition code, and I'll say my new addition is going to be pizza and pineapple, which is 2 things, but that's all right. It doesn't know that. It just knows it's a string. I hit enter, and it runs that line of code. It says my variable addition is now pizza and pineapple. Then I run my append code, right? And we'll see over here we've added pizza and pineapple to the end of my list. And then when we run our user entries code, it stores that user entries. So I think you're getting the point here. Like it's a really handy way of, in addition to using print statements, seeing exactly what the values of their various variables are, sort of one step at a time as you go through your code, which is super, super cool. Yeah, so that's a real short preview into the debugger and compiled versus interpreted languages, and one of the examples is the availability of this debugger. All right, so I'll close that up real quick. How are we for time? Well, we're doing all right. Let's introduce 2 more things. Why not? We're young. We're crazy. We're programming. It's Sunday night. It's gonna be great. Let's talk about one more type of loop and one more data structure, and then I'll get you out of here. Ooh, Palmer has a question for the future. In the PyCode world, do you end up getting into GUI design? Ah, good question. Yeah, you totally can. There are a couple of standard modules, which is sort of the equivalent of a library. I guess they're libraries as well as modules. In any case, ways of including other people's code into your project. There are a handful of standard libraries that allow you to build graphical applications in Python. The couple that I've played around with are called, just to spell them out if you want to play with them, tkinter, Tkinter, and TCL, I think, is the other one, or TK is the other one. And they're good for like basic GUI interfaces, like having a display with buttons and text fields and text boxes, and including basic images and sort of changing colors. Python is not really the language you'll be writing in if you wanted to do really graphics-intensive things. Although there are various ways to generate like mathematical plots and visual representations of data, but for like rendering 3D objects, that's not what you would do. But I've used both of those libraries. I asked this assuming you can use the Py for more than text-based programming. Yeah, you totally can. You could do an interactive device that allows you to drag things around. You there are also, there's a variety of libraries you could use to hook up to the Pi to do various visual or graphical things. Depending on how like graphically intense you wanted to get, you might end up using Python to trigger something else. I'm thinking to my work at the museum, for example. Not that any of it's running on Python because it's quite old. But you might have some Python code that was running your servos and motors and buttons, and then playing back an animation, and that animation would probably be pre-rendered, and you just say, hey, play this now, or play this generatively, and that part of like real-time rendering might not be in Python, only because Python's, like I say, as an interpreted language, not as efficient, but you totally can do graphical interfaces and various representations of data in Python, if that's a fair answer. Yeah. What do we want? Oh, while loops I was going to talk about, because they're super useful and they kind of go back to Chris's question earlier. We'll start a new bit of code. We'll call it the while example program. And this, Paul, that's a really fair question of like, hey, it's all typing stuff. When do we get to the interactivity stuff? We will totally get there. This is kind of the walk before we can run. But hopefully, at least you two nerds that I see in the chat this evening, I know you were both with us through the Arduino series. Hopefully, though we're kind of blowing through this and the syntax is a little bit new, hopefully it's feeling a little bit easier to grok because a lot of these concepts map pretty directly to things we learned in the Arduino session, if that sort of makes sense. Hopefully. So while loops, much like in Arduino land, are a loop that will repeat forever until a condition is false. So let's do a real basic example. We'll start with a variable called num. We'll start at 0. We'll say while num is less than 10, num equals num plus 1. Oh, actually, let's do a little bit of shorthand that I promised you. We'll do num plus equals 1. And this, much like in C or C++, says, hey, this should be increased by 1. We could also say this should be multiplied by 2. This should be divided by 3. Putting the operator next to the equal sign says this existing value should be sort of modified by the thing on the other side of the equal sign. So in this case, we're going to increase our number until it is greater than 10, and we'll print it out as we go. And at the end, we'll print finished. Right, so when we run this code, we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and finish. You'll see we didn't print a 0 because in our loop, we printed we incremented our number before we printed it. So our first number that we printed was 1. And you'll see much like our if statement, right? We don't need brackets or parentheses or anything around this, although we can add parentheses here if it makes our intention clearer. And it runs just fine. We put a colon to indicate that we're starting our sort of interior bracket, and then it's this indentation, this white space here, that tells us where our loop actually is. You can see that this finished print is outside of the loop because it's not indented, right? We've gone back to our earlier indentation level, which means that the end of our loop must be right here, right? So let's do Chris's example from earlier where we incremented through, we continually asked the user for new input until they gave us a blank line. Yeah, Chris, I love it. They're so good. So let's see. So I'm going to create a new variable called in, and I'm going to use this special value called none. None represents an object that is not there yet. Actually, I shouldn't use in because that's a keyword. I'll call it user input equals none. Let's see. How do I want to structure this, actually? Let's see. I should give this some kind of dummy value is what I should do here. So I'll say user input equals the string x, while user input not equals the empty string. I'll say we'll compress a couple things into one. MyList.append input, please give me more foods. Right? This is going to sort of combine two things into one that we were doing earlier. Earlier, we took the value of this input, assigned it to a variable, and then appended that variable to the list. We can just squish all that together into one line if we wanted to, right? We're going to append something to this list. What's it going to be? It's going to be whatever we get back from input, right? And then at the end, we'll print my list. Let's see if this does what I want it to do. I have some... Oh, I forgot my colon there. It says invalid syntax because I didn't put a colon in. Let's run that again. Missing parentheses. I have some parentheses missing. But where? Oh. My print statement needs So this is funny. Python 3 added this really helpful thing because in Python 2 you did not need parentheses around print statements, and in Python 3 you do. So they add this thing that says missing parentheses and call to print. Did you mean to not screw this up? Thanks, Python 3. I did not. Another food. How about a donut? How about an eggplant? How about a fish cake and a garga ball and a happy meal? And then an empty string. Oops. So let's see here. So what I would like to, so something is not right here. For some reason giving it an empty string is not, you know what it is? I see you probably have spotted it here. Is that I was counting on having this user input variable change as I took input, and then I got clever and I didn't use that variable inside my loop. So let's fix that. So I'll say here, user input equals input and mylist.append user input. Hopefully that will work better. All right, we'll run this now and we'll say we want a donut, an egg, a flat cake, greens, and a hen's leg. And then I give it an empty string, and that tells it at the end here, right? My user input function was an empty string. We added that to our list, and then we exited from our loop because this was no longer true. So sort of the side product of it here, you'll see we have apple, banana, carrot, donut, and so on, but we also have this empty string at the end of our list, which is not necessarily what we want. So if I was going to be really tidy about this, I'd put an if statement in here and say if user input not equals empty string, only then append to our list, right? So I don't end up with this dangling empty string at the end here. Give me more foods. Oh, a donut and an egg, and that's all. And we'll see this time, because that if statement triggered, I don't have my dangling empty string at the end here, right? So you can use the while statement with numerical comparisons or with string comparisons. I could also say while len mylist is less than 7, right? So I would have a maximum number that it would allow me to input. And I guess a minimum number too, because I won't be able to exit this list until I have 7 objects in it, right? So give me more foods. I'll say pizza. I'll say peas. I'll say pizza. I'll say pizza. I'll say pizza. And then I have 7 objects in my list, and so my list exited because this became false, right? The length of my list became equal to 7, and so it was not less than 7, so this was no longer true, so we exited our list and came out of it here. Yeah. Does that make sense? So, a while loop is something that's going to repeat over and over again until this thing at the beginning becomes false. That's going to be some kind of comparison. It could, honestly, it could be a statement that is always true. I could say while true, and then no matter what I type here, there is nothing I can type that will cause me to exit this list. If you find yourself in this situation, by the way, whether on purpose or an accident, and you have no way of exiting your loop, you can use this stop button up here to manually stop your program. So let's say, even if I had len mylist, let's say I had, forgotten to put an inequality up there and just said, wow, length of my list, and I discovered after the fact that I had no way to exit it, I could just hit the stop button and kill my program so I wasn't stuck in it forever. So, little thing you can do there. So, that's the basics of while loops. Questions? Comments? Issues? Concern? Shout them out if you got them. I'm going to do one more data structure, and then we will call it a night. Let's start one more file here, and I will show you the slide for it. It's the last structure we're going to have, and this is kind of where things start to get a little bit more advanced than what we would do in Arduino land, where really the only built-in data structure we have is the array. In Python, we have a couple more that are really useful. The one that I find myself using a lot is the dictionary. A dictionary is a collection that doesn't reference objects by position, but rather references them using a key and value lookup system. So here's what that looks like. You have a collection, you define it with an equal sign, you use curly brackets instead of square brackets, and then you have this notation. You still have things separated by commas in a list, right? But your first object is going to be the key that tells us to look at the position of the second object, right? And then you reference them by using brackets. Let me just show you. Right, let's create a dictionary example here. Dictionary example, and we'll save it. Let's say we're going to make a list of temperatures today by location. So I'm going to make what I'd like to do is, if I had a list of sequential things, listing them in a sort of, in a specific order might make sense. But for a collection of the temperatures in a place, there's not really, a logical given like ordering to them. And moreover, what I really want to know is, say, I want to ask this collection of objects, hey, what was the temperature, not in position 3, I want to say, what was the temperature in Chicago today, and have it give me back a value. And that's what a dictionary is good for, sort of looking up values by a key that you give them. So let me show you the syntax. Let's create a dictionary called temps. So temps is equal to, and we'll create a list of key value pairs. Again, keys and values can be any object, could be strings, could be numbers, could be lists, could be objects. In our case, let's do a list where the keys are all strings and the values are numbers, say, in degrees Fahrenheit, right? So let's say the temperature, I know California's been really hot this week, Francisco, let's say was 92 today, and New York has been not quite as hot. New York has been, let's say New York was 82, right? Close curly brackets. So this syntax is really important. We'll see we've got a key, that's what we're going to look up by, followed by a colon, and then the value that it references, and then we separate it from the next object with a comma here. So the way we get that value out is by using a very similar structure as if we were using a list, only this time, instead of returning the value at a specific place, it's going to return the value referenced by a specific key. So if I print temps Chicago, and I run that code, I get back 76. The different bracket is important? Yes, very much so. Yeah, the different bracket is how it knows you mean to instantiate a dictionary instead of a list. So the curly bracket is critical here. If I say print temps New York, I will get the temperature back in New York. If I index by something that's not in the key, like if I say what is the temperature in Flagstaff, which I don't know why that's on my mind, right? It'll throw an error. It'll say key error Flagstaff. Because I don't have a key, I don't have a thing to look up by the value Flagstaff. So I've thrown an error and I've stopped executing, right? So this is really good for structured data that doesn't quite necessarily make sense to reference in a linear order, but rather to look up by a specific value. So, oops, that's a view we don't need it all tonight. So the dictionary is super useful. There's also a way of, if you're curious, of getting all of your keys, which is a really useful thing. Like, let's say you found yourself in a situation where, it would be useful to have all the cities that we had temperature data for. You can use the following. You can say the name of your dictionary dot keys, and that will give you a list of all of your keys in your dictionary. So it says Chicago, San Francisco, and New York, right? Let's give you there's a list of things you can go through. Once you have that list, just like any other list, you can iterate through it. Something like this. Using our for loop that we saw earlier, we could say for k in temps.keys, print k followed by, let's do this right, the temperature today in K. And remember, K is the key. That's this first value here on this side of each of the colons. So Chicago, San Francisco, New York. The value today in key was, and then we will look up the value that is associated to it in our dictionary, temps K. All right, and we'll do that for each of the keys in our dictionary. Oops. Can I int to string? Okay. We have this integer to string error again here. So what I want is for this temperature to be cast as a string. And I'll say the temperature today in Chicago was 76. Temperature today in San Francisco was 92. Temperature today in New York was 82. Palmer has a question. Could you have the code pull from the National Weather Service and update the high temps daily? Definitely not in today's scope, but definitely yes. Yeah. Pulling from web APIs or doing like website scraping is definitely in scope for Python. I mean, not for tonight. But yeah, that is reaching out to things over the internet using either built-in libraries or directly accessing and parsing APIs or HTML is totally in scope. One thing, the other half of that equation, obviously, Palmer, would be how you wanted to store that data on your computer. But, thinking back to some of the examples we looked at last week, like an on-your-wall weather station, you could have a Pi with some display that you had generated that would reach out to the National Weather Service at regular intervals. And there's a way in Linux on the Pi to say, rather than having your program running all the time and triggering itself to go out and get this information, you might write a little script that just gets the new data and have the Raspberry Pi, the sort of computer side of it, scheduled to run that program every 15 minutes, say. It's a little, a little difference. Then you would need some way to store that data in some kind of file, and then presumably a program that would be reading that file and updating the data on your display, whatever that looked like, if that makes sense. But yeah, totally a thing you can, and that people have done, which is super cool. So dictionaries, super powerful thing, super cool. One little example of a thing you can do with dictionaries that I've used quite a bit is using them to hold not only to hold like key and value data, but to use it as like a tracking mechanism for how many times you've seen a specific object, just to sort of like stir the pot on what you can do with dictionaries. So let's start a new sample code called word count, and we'll need some text. Let's see here. Should have downloaded this beforehand, but that's all right. Complete works of Shakespeare in text. Let's see. How can I get this all on one page? No, let's pick our favorite Shakespeare play. Let's take Julius Caesar. Entire play, and I will copy this whole play into a text file. Open my text editor here. I really should have done this in advance, but that's all right. So just because I want this to be just plain text and I don't need any of the formatting, let's go back up to the top and make sure we don't have any extraneous headers or anything. I'm going to save this in the same place as my programs are in. Chug-a-lugging a little bit here. The web browser functionality is will often make your Pi a little bit slow. And that's just because the modern web is not meant to run on too small of an amount of RAM. I'll call this Shakespeare.txt. So I'm going to make use of a couple functions that we haven't talked about yet. How to open and access files, but for the sake of having a big corpus text to work with, we'll blow through this and we'll talk about file reading and writing in more detail at some point, but just trust me for now. Say with open Shakespeare.txt read as in file, for line in file, for letter in line, right? So not without going too deep down the rabbit hole, this open statement basically allows you to access the contents of a text file as if each of the individual lines in it were strings in a list, right? So what I'm going to do is step through that whole giant list that represents this text file of Julius Caesar, line by line. And then, because each line is a string, which is essentially a list, I can step through it letter by letter. So I'm going to make a dictionary called letter count. I'm going to start as an empty dictionary, right? You can start an empty dictionary. You could also say, open, curly brackets with nothing inside them. Doesn't mean it's a dictionary with nothing in it yet. But here's what I'll do for every letter in that file. Well, let's just make sure I got this part right first before I start adding any other code. Going back to my philosophy of coding that you should sort of do things incrementally, I want to make sure I have this looping structure set up correct, and then I want to do some fun things with it. I know we're getting a little bit out in the weeds so far, but it'll be fun. So what I'm going to do before I start setting up some code in here to count the number of each letter in Julius Caesar, just to make sure I have this loop set up, if I just try and run this, I'll get an error because it says, hey, you have a loop with nothing in it. I'm going to assume I've messed up somewhere, or you have, right? So to prevent there just being an empty loop here, I'm going to use this special function called pass. Pass does nothing. It's a placeholder. It literally says, hey, do nothing. But it prevents this from being an entirely empty loop, which will mean that it will parse correctly, and we'll see it's run and it's done nothing, right? Totally good. So we know the loop itself is working. All right, so I'll say for each letter in our line, I'll say if letter is in letter count.keys, right? If we've seen this letter before, let's see, let's do this the other way around. If letter not in letter count.keys, if I've never seen this letter before, I'll say letter count letter equals 1. The first time we've seen this letter. Else, if we have seen this letter before, letter count letter plus equals 1. And then at the end, when we're all the way through, we're going to print our letter count. Let's hope this works. There we go. So now this is a list of the counts of all of the different letters and I guess various other characters. You see this /n is new line. That's like a return. What else do we have in here? We have single quotes. We have exclamation point. Various all the time that different characters appear in various amounts in Julius Caesar. Hi, Nate. How are you? It is better late than never. Nate, we're a little bit out in the weeds this evening. Of course, we're just talking about Python dictionaries, like you do. What we just did, Nate, was get a letter count of how many of all the occurrences of various letters and symbols in Julius Caesar, and of course we can apply all of the functionalities that we saw earlier to exactly this thing, right? Maybe we want to maybe we will only want to count uppercase and lower cases of the same letter in the same place. Yeah, Chris. Oh, you're so far ahead of me. Yes. So if I say, let's see, what's going to be the cleanest way to do this? So I could sprinkle dot lowers throughout all of this, but I think what I will do is say L equals letter dot lower, and we'll just do it once. We'll say get the lowercase representation of the letter we're looking at, and then we'll just replace letter with L in each of these. Run that again, and now we'll see we're only looking at, capital A and lowercase a are the same in each of these cases. We can also, actually, I wonder, let's see. I think this is this is one of the things that I would Google the syntax of, but since I'm making up this example on the spot, let's see. Yeah, So what I will do, this sorted function returns your list sorted alphabetically, which is a really handy thing. So what I will do is, instead of printing out just the letter count dictionary, which you'll see is kind of arbitrarily ordered, right? I've got A, C, T, space, I. It'd be really kind of better to see this in alphabetical order, more to speak. Chris says, can you sort lists? Chris, we're vibing tonight, and I love it. You totally can. I want to get to list sorting in a more formal way in a future one, because there are cleaner ways to do this. But one way you could do it is say, you see, if I just do sorted on a dictionary, what I get back is a sorted list of keys, which is fine, but I really want to see key and value. So what I'll do is use a for loop. I'll say for L in sorted letter count, print L and a colon, and then the value in letter count of that letter. So that'll print on successive lines. Let's see. If I put the colon in for L in, and if I have the right number of parentheses, and if I have this wrapped in a string function, there we go. Did it. Can you print as more of a table than a list? Chris, I think we were on the same page there. Yes. So now we have each of our, and then since it's sorting out punctuation first, we can see, at least in this text version of Julius Caesar that I just downloaded, there are 408 semicolons. There are 6,974 instances of the letter A, and so on. And if I can anticipate your next question, Chris, could we sort this by highest occurrence rather than alphabetical? Yes, we could, but that's one of the topics I'm going to pin for a later week, because it's going to make a little more sense when we know how to work with lambda functions, which are ways of representing manipulations of collections of data in a succinct way, in a way that, frankly, I'm not quite prepared to do tonight. So I want to make sure I tell you it a little bit more cleanly. You can imagine building a list out of these and sorting it manually, but there is a clean way to do it, and I want to do justice to that. So yeah, totally a thing you can do. So Palmer, to go back to an earlier question, like in terms of things that I on a daily basis use Python to do, I mean, it's not counting letters in Julius Caesar, but for stuff like this, I reach for Python. I'll give you an example. Can I show it? I don't think so. I don't think it's on the Pi. I think it's only on my work computer at the moment. I am dealing with some assembly code at the moment for a project at work that's being spit out of one program in one text format. Actually, I'll give you a little typed example to make it more clear. I have some assembly that basically comes out as move AX 2000. Multiply that by 1,000 lines of various formats and types and various things, right? Not really necessary to know exactly what it is, but I need it in a different format. I need it to be in a format that says something. This is just preparing my brain to go back to work tomorrow, I suppose. What I need is something that is formatted slightly differently, right? I need the order of the operands to be reversed. I need all the numbers to be explicitly in hex. I need all these registers to have a % sign in front of them and so on, right? So it's essentially, at the end of the day, it's a text formatting issue, but with some complications and some rules, and there's sort of some edge cases where, if this is preceded by a couple of things, I have to do something slightly different. And this kind of data manipulation and lookup is something that's really easy to do in Python. So that's the kind of project I reach to it for. But that's just me. Like, that's the kind of stuff that I do. If I was doing a project to especially anything to do with text or with lookup, like if I was making a bot to tweet out a random sentence from, a random sentence from Barack Obama and a random sentence from, Joe Biden every half an hour. That's essentially a text lookup problem in a database, and then a library that somebody else has written to do the tweeting, right? Perfect example for Python. Weather station example, reaching out to the internet and getting data, essentially just text and data manipulation. Putting it out on display, a little bit more complicated, but really not too bad. Could certainly do in something like Python. And certainly all the physical interactivity stuff that we talked about, or we will talk about, servo motors, switches, buttons, LEDs, all that stuff we can also do with built-in libraries. But just to give you a flavor of why I prize starting with things like data structures and loops and text input is because that's what I use it for most often. Is this letter count example is a little bit silly. But you can imagine that this file was not, say, the works of Julius Caesar, but was a serial dump from a file that I've got hooked up to a data line that's got a couple million lines of code that is I want to find how many occurrences of various serial transmissions there are. Well, you can whip together some code like this in a few minutes, right? And just get the analysis done, have it spit out in your shell, and you're ready to rock and roll. So we'll be doing a lot more than that, but that's where I find Python's home to be, is because it's really easy to write stuff like this, if that makes sense. I think, I'm gonna double check my slides here. I think that's the last thing. Yeah, we're on to the bonus slides after that, which is just some pinouts and some remember way back in March when we talked about what is a computer? Those slides are always in the back of the slides if you ever want to review. Chris says, makes me a lot less scared of doing a Python program. Yeah, Python is great. Python is I think it's really easy to type. If I was going to introduce someone to a new programming language on a computer today, especially if they'd had a little bit of familiarity with coding, it'd be Python. It's really generous. It has some great data structures. We'll talk about object-oriented programming, more defining not just collections of basic data, but objects that have their own parameters and their own methods to do things with. And we'll talk about interactivity, defining how objects interact in the real world with the Pi. But not tonight. We're going to call it for tonight. Tonight has been great. We went a little bit beyond a 90-minute goal, but not too far. So I hope what I really think the best way to learn this stuff is to play around with it. Give yourself a project, play with input and output, play with lists and data structures and dictionaries. And we'll attack some more fun stuff next week. Closing business, as always, if you have questions, comments, issues, concerns, leave them in the comments of this video or find me on Twitter at JeffersGlass. All of the slides from tonight and some of this code, whenever I can be bothered to put it up, will be on the website jeff.glass/electronicsbash. Thanks, Palmer. Thanks, Chris. Nate, good to see you. I hope you're well. And whoever else is watching out there, I hope you're having a lovely and cool evening. Stay safe. As always, it is a privilege and an honor to be with you here on these Sunday nights. It really does give me the strength to go out into what is a pretty tough world out there and do what I need to do. So thank you for being my place of safety and refuge here on these Sunday nights. I really enjoy being here with you. You are the best. Of course, just as we were saying it, my stream controller has crashed, so instead of being the graceful outro that I usually prize, it's going to be like me looking off into the distance, clicking on a thing, fading out, fading out, fading out.